Hello everyone. Today, we will study the positioning and sheet feeding mechanisms of sheet-fed printing presses. For sheet-fed printing presses, after the substrate is successfully separated by the feeding device, it generally undergoes two processes, positioning and feeding. The positioning of the substrate is typically performed on the feed board. The purpose of positioning is to ensure that the substrate is correctly aligned relative to the printing plate's graphics before entering the printing unit. This guarantees accurate placement of the graphics on the printed product for each impression, and is a prerequisite for proper register between sheets, colors, and front or back sides. For color printing, this is especially critical. Each color must be printed precisely at its designated position, with all ink layers overlapping accurately, to faithfully reproduce the original image's rich colors. To facilitate on-press inspection of registration accuracy, 7 to 8 cross marks, register marks, or guidelines are exposed at identical positions around each printing plate during plate making. This diagram shows a standard offset printing test plate. During printing, the cross marks are transferred to the substrate along with the plate's graphics. By checking and adjusting the alignment of these cross marks, the registration of the printed graphics can be ensured. The positioning mechanism, also called the register system, ensures that the substrate is correctly positioned relative to the plate's graphics before printing, maintaining consistent blank margins around the substrate. The components that control the substrate's vertical front-to-back positioning and skew correction are called front guides, front lays. The components that control the substrate's lateral left-to-right positioning are called side guides, side lays. Principles of substrate positioning. An object on a plane has 3 degrees of freedom: x-axis, left-right direction, and y-axis, front-back direction. Correspondingly, the substrate on the feed board has 3 degrees of freedom: lateral, left-right movement, longitudinal, front-back movement, and skew, tilt, adjustment. The positioning process involves restricting these degrees of freedom. The positioning process of the substrate. The positioning process is as follows. Firstly, 2 front gauges are used for front-back direction and skew positioning, and then 1 side gauge is used for left-right direction positioning. When the leading edge bite of the substrate is positioned on the 2 front gauge planes, not only is the front and back position of the substrate determined, but also the leading edge of the substrate is ensured to be parallel to the bus bar of the printing cylinder. That is, the 2 degrees of freedom front and back and skewing of the substrate in the plane are restricted. Typically, 4 or more front lays are installed on the machine's front guide shaft. For smaller print formats, the 2 inner front lays are used for positioning. For larger formats or thinner substrates, the 2 outer front lays are employed, while the others only support the sheet edge. The distance from the front lays to the substrate edge is usually 1/5 to 1/4 of the substrate width. After the front registration is completed, the side guide positions the substrate in the left-right direction. Once the side edge of the substrate is registered against one side guide surface, its left-right degree of freedom is restricted. At this point, the 3 degrees of freedom of the substrate in the plane, front, back, left, right, and skew are all restricted, accurately positioning the substrate in the specified location and completing the pre-printing registration requirements. To ensure that the same side edge of the substrate is used for registration when printing on the reverse side, side guides are typically installed on both sides of the printing press's paper feed board. Only 1 side guide is used during each print run, one for printing the front side, and the other for printing the reverse side. Conveyance of substrates. After the substrate is registered, it is typically stationary on the paper feed board. Subsequently, The registered substrate accelerates from rest to the surface rotational speed of the impression cylinder and is delivered to the impression cylinder for printing. This process is called the paper transfer process. There are generally two basic forms of substrate conveyance: direct paper transfer and indirect paper transfer. Direct paper transfer refers to the situation where, after the substrate is registered on the paper feed table, the impression cylinder directly picks up the paper from the table for printing. Indirect paper transfer refers to the situation where a specialized paper transfer device transmits the registered substrate from the paper feed table to the impression cylinder for printing. Indirect paper transfer can be divided into three categories based on its motion mode: oscillating paper transfer devices, rotating paper transfer devices, and overrunning paper transfer devices. Oscillating paper transfer devices are further classified into upper swing and lower swing types according to their installation positions. The upper swing type includes fixed axis oscillation and moving axis oscillation. Rotating paper transfer devices can be divided into continuous rotation and intermittent rotation types based on different motion modes. Since the paper transfer device in indirect paper transfer picks up the substrate stationary on the paper feed board in a static state and then gradually accelerates when its speed matches the surface linear velocity of the impression cylinder, it transfers the substrate to the impression cylinder or transfer cylinder. As the substrate is transferred in a stationary or relatively stationary state, the handover is smooth with minimal impact and vibration, making this method widely adopted. Although indirect paper transfer devices have different structural forms, they all use paper transfer grippers to convey the substrate, so their motion requirements are the same. First, when the paper transfer gripper hands over with the front guide, it should be in a stationary or relatively stationary state, summarized as zero-speed paper pickup. Second, the transfer speed should accelerate smoothly, without impact, i.e., smooth acceleration. Third, the paper transfer gripper and the cylinder should intersect at the tangent point, with the gripper's motion speed equal to the cylinder's surface linear velocity. This means the substrate handover should be completed in a relatively stationary state, i.e., equal speed handover. Fourth, there should be an overlapping handover time during paper pickup and transfer to prevent substrate loss of control and ensure transfer accuracy, summarized as no loss of control. That concludes today's lesson.